Hey everybody, Chris Kresser here. Welcome to another episode of Revolution Health Radio. Today I'm going to be talking with Dr. Sara Gottfried about aging, genetics, the exposome, and the environment. Dr. Gottfried is a Harvard-educated physician and two-time New York Times bestselling author. In her new book, Younger, she shows how to reset gene expression in order to slow down aging and lengthen health span. Now, we're going to get back to the listener Q&A format pretty soon. We've been doing some interviews lately with Rob Wolf and Stefan Guillenet about their books, and this will be the last one of these for a little while. But as you probably know, I'm a voracious reader, and this kind of research and learning is a big part of what I do, and I also consider it to be my job to bring these new resources to your attention when they become available if I think they're valuable. And it just so happened that three of the people that I respect the most in terms of their work and their perspective have published books almost back to back. And in particular, with Sara's book, Younger, this is one of the few popular resources that goes into depth but is still accessible on genetics and the exposome and aging. And those are topics that, we've talked a lot about the relationship between genes and the exposome on my blog and a little bit on the podcast, but we haven't gone into much detail on those topics as they relate to aging and healthy aging, which of course is a concern for everybody. And Sara is one of the people that I know that has done the deepest dive in this area, and she knows more about it than just about anybody. So I'm really excited to welcome her on the show and to share some of this knowledge with all of you. So without further ado, let's do that. Hey everyone, if you're like most people I know, you don't have the time or the desire or training for that matter to sift through the hundreds of medical studies that are published each month. But whether you're struggling with a chronic health problem or just want to maintain your health and live as long as possible, it's important to stay informed about the latest research and how it might affect your well-being. And let's face it, it's easy to get overwhelmed by all the conflicting stories in the media. You need a source of unbiased information that you can rely on, one that's easy to understand without too much jargon and full of practical tips that you can put into action. That's where my website, chriskresser.com, comes in. You'll find in-depth, evidence-based articles on a wide range of health and nutrition topics each week. You'll also find over 10 free ebooks on subjects like effortless weight loss, healing your gut, thyroid disorders, and natural skincare, as well as online classes and programs on optimizing nutrition for fertility and pregnancy and lowering your cholesterol without drugs. What you won't find is any third-party advertising, corporate influence, or hype-driven, headline-grabbing stories with a lot of drama but no substance. You just get the real inside scoop on the health issues that matter to you most. So head over to chriskresser.com and check it out. And when you sign up for my email newsletter, you'll get instant access to my award-winning 63-page ebook, 9 Steps to Perfect Health. It's like an instruction manual for preventing and reversing disease and living a long and healthy life. Okay, now back to the show. Sara Gottfried, such a pleasure to have you back on the show.
Happy to be here, Chris. Hi.
So I'm excited about today because I have definitely, written and spoken about genetics and epigenetics and the exposome on my blog and podcast, but I haven't really done it in the context of aging well. And that's really what your latest book, Younger, is all about. And it's something that really spans all ages, demographics. There's nobody that's not interested in aging well, at least on some level. How interested they are and how much they're changing their behavior as a result is a different question. But, I think if you ask just about anyone on the street, they would like to age well. So I'm really looking forward to diving into this with you.
Yeah, thank you. I agree with you. I think there's no lower limit on age or even an upper limit. Although, sometimes it's the big birthdays that get you more intrigued. I just turned 50. You had 40 a couple of years ago, but, I think a lot of people don't know that aging can be happening at a faster clip than they realize.
Right.
So that's what I want to bring attention to.
It can be a birthday for some people, and for other people, it can be a kind of really an extreme kind of stress event or maybe an injury or an illness. And you yourself diagnosed yourself in kind of stress failure or the failure state, as you refer to it. Was that the turning point for you? Tell us a little more about what happened there.
Yeah, I definitely had a failure state that occurred 5 years ago. And I just want to apologize here at the beginning because I've got a bit of a voice failure state today. So hopefully we can laugh a bit, which helps it immensely. So for me, I think of these failure states as a failure of homeostasis. And I remember you talked about this in your show with Pete Attia, and you and I have talked about this for years, but there's a lot of different failure states. It could be a failure of the stress response system, which was my story. It can be cancer, it can be SIRS, it can be depression, fatty liver, diabetes. So what happened in my case was when I was 44, I got very interested in the science of telomeres. Mm-hmm. And this in part is because we have a luminous neighbor, Elizabeth Blackburn, who got the Nobel Prize along with two others in 2009 for her work on telomeres. So I imagine your audience has heard of telomeres before. They're the little caps on chromosomes that are a marker of your cellular aging process. So it's a proxy for biological aging compared with your chronological aging. Mm-hmm. So at 44, I thought I was doing great. I thought I was aging well. My hormones were in a healthy place. I was a yoga teacher. I was relatively sane, but this test showed otherwise. So at 44, I had the telomere length of a 64-year-old woman. Uh-huh. And nobody wants a result like that.
Yeah, a little bit of a wake-up call, huh?
Huge wake-up call. So, from that test, I concluded that I was aging poorly and I needed to do something about it. And I think you may do this too. When I have a health crisis like this that can sometimes create fear and humility, what I do in response is to dive into literature. Mm-hmm. So knowledge really becomes the best salve for me. Mm-hmm. So I dove into the studies looking at telomere science and accelerated aging. That's how I created this functional medicine protocol that became my new book, Younger. But I should add that it wasn't just my telomeres in isolation. It was part of a larger narrative. So before the telomere test, I definitely had problems with my control system for stress, my HPA axis, the hypothalamic pituitary adrenal axis. And this went on for about a decade, at least, that I was measuring and looking at. So at 35, I had a serum cortisol that was 3 times what it should be. I had a fasting blood sugar of about 110, a hemoglobin A1C that was around 5.8 to 6. So there were multiple biomarkers showing me that my homeostatic system was toast. Mm-hmm. So I had fried it. I needed to surrender to kind of a new way of thinking about it, a new paradigm in order to heal it.
That's interesting because from one perspective, you could look at that and just say, oh, too bad, I have bad genes. And that's just the deck that I was dealt. But of course, that's not actually the way to look at it, is it?
It's definitely not. I mean, I think, I imagine you were taught this as well, but I went through medical school beginning in 1989. And at that time, we thought that your genes were probably your fate. Mm-hmm. So the idea that environment plays such a large role, that's relatively new. That's been, the last 12 to 15 years. So of course, the gene environment interaction is complex. And at the risk of oversimplifying, I think about the 90-10 rule here. So the idea, which you've talked about in your amazing podcast, is that genes load the gun, but environment pulls the trigger. Honestly, I want a less violent analogy.
Yeah, we've got enough of the war analogies all through medicine, don't we?
We totally do. Mm-hmm. But it's a helpful way to look at the relative weight of your genetics that you got from your parents versus environment. And when it comes to chronic disease or the signs of aging, genes are only about 10% of the story. Environment is 90%, much of which is under your control.
But let's use a gardening analogy. So you need good seeds, right? Healthy seeds in order to grow a plant. But so much more of it is the water and the quality of the soil and the sun and the care of the gardener, making sure that weeds don't, take over and get in the way. How's that? Are we getting closer? I think it
It's so
works.
much better. So
All
much
right.
better. That's our theme.
Okay, great. Now we just need a short, pithy way of referring to it in 7 or 8 words or whatever the other one is. But we'll work on that and get back to everybody. All right. So yes, definitely we've talked about this in other contexts where 85 to 90% of the chronic disease burden has been estimated to be related to environmental factors. Certainly our genes determine what our predispositions are. And, I always explain this to my patients is like, one person, when they're exposed to our modern diet and lifestyle, will develop rheumatoid arthritis, whereas another person will develop multiple sclerosis, whereas yet another person will develop, IBS or inflammatory bowel disease. And to me, that's, genes are probably both our own genes and then the genes of our microbiome are what are driving how the actual expression of disease.
That's right. And I think it's a helpful place to start because it gives you probabilities. It helps you focus on maybe what your vulnerabilities are. And, a good example here is I probably have some genes related to my HPA axis that are different than your system.
Mm-hmm.
And so the way that, my life has been constructed, the way it's been architected has made some of those genes turn on. It's silenced other genes. In your case, I think you've shared this publicly before, you have a vulnerability with your gut function.
Yeah.
So we all have different vulnerabilities and it relates to our exposome, how that affects gene function, both the external factors and also the internal environment we create as a result of that exposome.
Absolutely. So in your book, you talk about this, you use this great term. I'm not sure if you came up with it or someone else did, but
No, I didn't.
inflammaging or inflammaging. There's different ways of pronouncing it. Inflammaging makes it sound like hemorrhaging, like this is very serious. We need to stop it. Inflammaging sounds almost a little like a French word or something, but I'm talking just about the phonetics. But of course, we're really referring to a combination of inflammation and aging here. So tell us more about what you learned in your deep dive about the contribution of inflammation to aging.
Yeah, I definitely call it inflammaging. It's not a sexy French word. It's an unfortunate combination, as you said, of inflammation and then how that accelerates the aging process. So I didn't come up with this term. It's something that I read about, but I think it's a helpful, kind of pin on which to hang a hat because it's a way of thinking about this process of inflammation, which is a through line really in all of functional medicine. I was trying to think before talking to you today, are there any conditions you can think of that don't have inflammation as part of the backstory?
I've tried to think of those for a long time, and I have not been able to come up with modern chronic disease that does not, where inflammation isn't implicated in some way.
Right. So I've been doing the same, so we'll have to keep sleuthing.
All right.
But
we can say a very high percentage, no matter what, whether we come up with 1 or 2, it's above 99%.
For sure. And, in my case, I definitely had this background of inflammation that accelerated the shortening of my telomeres. I have these short, stubby telomeres. I'll actually tell you towards the end about what's happened with my telomeres over time. But it shows up in different ways. For some people, it starts in their muscles. I also had an issue with this a couple of years ago. I went to a spa with my husband, who's a former athlete and, loves physical fitness. We went to a high intensity interval training class, and the instructor, who was 25 and gorgeous, wanted us to jump up and down on a jump box. And he put this 18-inch box in front of me. And I thought, I'm a former gymnast. I can do this. And I did it, and I was sort of proud of myself. And then he wanted us to do it, 13 more times and 3 sets. And I pretty much wiped out. Like I just realized that I didn't have those fast twitch fibers. I didn't have the jumping capability that I had in my 20s and 30s. So it was a, kind of another wake-up call where I believe that I had some issues with my mitochondria. I didn't have the power that I used to have in my muscles. And that's a common way of looking at the early signs of inflammation. Another way to look at it is, your memory recall, your executive functioning. That involves more inflammation in the brain and how that accelerates aging. So we all have different ways that aging can show up. For some people, it's in their face with, kind of more puffiness and wrinkles. So I think it's a helpful way to kind of think about the aging process.
Mm-hmm. Yeah, I would definitely agree. And it's especially the cognitive symptoms seem to be, from what I have seen in working with a lot of patients, one of the most reliable, observable indicators of inflammaging. Just this, difficulty with word recall, not being able to remember names or even common words, difficulty concentrating. And of course, with Alzheimer's and dementia, as prevalent as they've become and as serious as they are, it's one of the signs that should be triggering all of us, to get help when we start to notice that sort of thing, especially if it's happening earlier on in life, in the 40s and 50s.
For sure. And I would even go further and say, unfortunately, the symptoms of memory loss or having a problem with your hippocampus, that part of the brain that's involved in memory consolidation and emotional regulation, I want to address inflammaging ideally a few decades before the symptoms show up.
Mm-hmm.
So, for our listeners who are thinking, I walk into a room and I remember why I went there. I don't know what they're talking about with this memory issue. That's not my problem. These are things that you want to address ideally in your 30s and 40s, early 50s, before the symptoms begin.
Mm-hmm. So I want to switch gears a little bit and talk about some specific genes. There's been a lot of discussion in the blogosphere about MTHFR. A lot of people have heard of this gene by now. I've talked about it on the podcast several times with several different guests. But let's talk about some of the genes that people may be less familiar with, or some that are somewhat familiar, but you have an interesting take on. So the ones that come to mind are FTO, certainly APOE, especially since we're just talking about Alzheimer's and dementia, and maybe CHEK2, which is a breast cancer gene mutation that doesn't get as much play as BRCA and some of the other genes that are involved there. So why should people be paying attention to these, and what should they know about them in terms of, actionable steps they can take if they have polymorphisms in those genes?
Right. Well, I have variants of pretty much all of these genes. And I hope it's okay with you to give a little bit of the background of talking about this with you, because you and I have been in a mastermind together for years. And I remember when I first started writing this book and I said, guys, I've narrowed this down to 25 genes that I'm going to focus on in this new book. And you, along with the others, were like, okay, you've got to narrow it down further. 25 is just way too overwhelming.
Yeah.
So FTO, it's unfortunately named the fatso gene. I think of FTO as a nutrient sensor. It stands for fat mass and obesity associated gene. It's located on chromosome 16. And its job is that it's strongly associated with your fat, with your level of fat composition, so your body mass index, and consequently your risk of obesity and diabetes. So I have the variant. I have a large number of obesity genes. I joke that I'm genetically programmed to be a 200-pound diabetic with thinning hair, which is not exactly the picture of middle age that I have for myself.
Nor is it what you look like, but importantly.
Well, that's the benefit of environmental changes,
exposome,
right?
yes.
Exactly. So when you have the variant, the main thing that it does is you have sloppy control of leptin. So you knew I was going to work in hormones somewhere here. So hormones are so key, and genes control so much of hormonal balance. And leptin is the hormone that's responsible for satiety. It tells you to put the fork down. So for people who have a problem with this gene, they are hungry all the time. And that was certainly my story before I learned how to regulate this gene. And this gene is interesting because it's very prevalent in the Amish population. And one of the ways that the Amish regulate this gene, because you don't think of the Amish as being obese or diabetic, but one of the ways they regulate it is with hard physical labor.
Manual labor all day long. Yeah.
So that's certainly not what I do, but it turns out that even 30 minutes of moderate exercise every day can regulate this gene in a way that helps you prevent obesity and diabetes. You can also do it with your carb thresholds. So a lower carb food plan, that's kind of a murky, complicated topic because I think you need enough carbs to kind of take care of your adrenals and thyroid function, especially if you're female. But really defining your carb threshold can help with this gene, along with making sure that you get adequate fiber. So that's a really important gene. You also mentioned APOE.
APOE.
Which is, I think, one of the most fascinating genes. It's, as you mentioned, if you inherit one of the variants, APOE4, that can put you at a greater risk of Alzheimer's disease. So this is kind of known as the Alzheimer's gene. There's other Alzheimer's genes, but this is the one that's responsible for about 95% of the genetic risk of Alzheimer's. So this one, if you inherit one copy of the APOE4 allele, it gives you about a 2 to 3-fold increased risk of Alzheimer's disease. It's not, a death sentence, but it does increase your risk. If you inherit 2 copies, it's somewhere around a 8 to 15-fold increased risk. But this gene is a little bit complicated because, the number of different alleles, there's 4 of them. There's 3 that are kind of popular, but 4 total. And you can inherit the APOE2, the APOE3, the APOE4. So I happen to be an APOE2/3. And what that means, because this gene is in some ways also a nutrient sensor, especially how you respond to fat, and it's involved in the trafficking of cholesterol in your body. So what this means for me is that if I go on a low-fat diet, which was, kind of all the rage when I was in high school and college, it actually creates inflammation and increases my risk of heart disease. So not only is it modulating your risk of Alzheimer's, it also modulates your risk of heart disease. And it can give us some guidance about how tolerant you are of fat in your diet.
Right. And then check 2, that's an interesting one because it's, as I said, not one that gets as much airplay in terms of breast cancer risk.
Yeah, CHEK2 is super interesting. It's a tumor suppressor gene, so similar to BRCA1 and BRCA2 in that regard. But I had never heard of it, honestly. And I've done research on breast cancer. I've kind of followed the breast cancer field pretty carefully. But it wasn't until I sat down to make a list of all of the gene mutations related to breast cancer risk that I started to look at the literature on CHEK2. And in some ways, I feel like writing this book saved my life because I discovered as I made this list of gene mutations that I have the CHEK2 mutation. So what that means is I have about a 3-fold increased risk of breast cancer. So my lifetime risk of breast cancer is about 39%. For most women living in Northern California, that risk is about 12% lifetime risk. So that really got me into action in kind of a new way, in the way that I look at this particular gene and how to modulate its expression. I also have a greater risk of colon cancer. So what's recommended if you have a gene mutation like mine with CHEK2 is that you start mammograms and breast MRIs every 6 to 12 months, starting at age 40, colonoscopy every 5 years. So this was a big change, versus what I have been doing for breast cancer screening. But it also, in some ways, it's strangely liberating to learn about your genetics because it allows you to kind of accept your probabilities in a different way. It kind of gives you a place to focus with your lifestyle management and with your exposome. And, it's definitely changing the course of what I'm going to do to prevent breast cancer.
Yeah, I mean, I think this is really something that is shifting, and I'm glad to see it shifting. As all of my listeners will know, I have been a huge advocate of a personalized approach to diet and lifestyle and behavior, environmental exposome factors, and that was largely what my first book was based on. And part of the argument for personalization comes down to these differences in gene expression. And, that conversation comes up a lot in my patients who have elevated lipids like LDL particle number and lipoprotein little a. And the conversation I often have with them is, look, it may be that a low carb, high fat diet is good idea for a lot of people, but it's, we have clear evidence that it's driving your LDLP through the roof. And, we need to have a conversation about what the additive risk is there and what other alternatives there might be in terms of diet that would still meet your other needs without causing this increase in LDL particle number. And so it's just a much more nuanced, individualized way of looking at nutrition and diet than I think what the conversation that we had been having, for a couple decades leading up to this.
Yeah, well, this is why your wait list is so long, Chris, because I think this way of practicing that you and I have of being preventive, predictive, participatory, the 4P medicine, it's the future.
Mm-hmm.
At least I hope it's the future, because our healthcare system is completely broken.
Yeah.
But it allows us, to look at that issue of inflammation and to say, okay, here's the genetic contribution to the aggregate of inflammation in your body. What can we do about it? Like, how do your genetics point to a particular way of addressing your lifestyle design so that we can really dial this in and reduce your risk of chronic disease?
So along those lines, there are a couple other genes I would love to talk about that are really interesting. One, we've already kind of referred to in terms of the HPA axis and reprogramming of that by stressful events, and that can actually pass down from one generation to another, which is, I guess, not the greatest news since we don't have control over that. But as you said, it can be liberating to know that. FKBP5, and then the clock gene.
Yeah, the clock gene's a little simpler, so maybe I'll start with that one.
Okay, yeah.
The clock gene's on chromosome 12. It modulates your circadian rhythm, your, ideally 24-hour sleep-wake cycle. And if you have the bad variant, which once again I have, you have higher blood ghrelin levels. So that's the hormone that makes you hungry.
Mm-hmm. Appetite.
Increases appetite, makes you pick up the fork, as opposed to leptin, which makes you put down the fork. And you have resistance to weight loss. So pretty much, there's so many hormones that are released on a circadian rhythm. They're affected as well by the clock gene. And the idea here is that you have thousands of biological patterns in your body that are regulated by the circadian rhythm. And we have an epidemic of dyscircadianism. So if you inherit the variant of the clock gene, the idea is to really protect your circadian rhythm, to keep your body on a normal sleep-wake cycle. And that will help you regulate your hormone production. So for me, if I want to lose weight, I have all these obesity genes that I'm trying to manage. I have to get 7 to 8.5 hours of sleep if I want to lose weight. So weight loss isn't the only factor, but it's one of the outcomes that has been probably defined the best when it comes to the clock gene.
And this, this is something we've talked about a lot on the show, how the circadian rhythm is just absolutely crucial to all aspects of health. Every single cell in the body responds to it. And even the simplest single-celled organism appears to be impacted by the 24/7 light-dark cycle. So, in Stephan Guyenet's most recent book, we just had him on the show. We're talking about the neurobiology of weight regulation. He believes, and I think the research supports this, that aside from diet, sleep is possibly, and circadian regulation is possibly the second most significant controllable factor when it comes to weight gain and weight loss. So these are really important things to be paying attention to.
I totally agree. I mean, I think that restorative sleep may be as close to a panacea as we have in functional medicine. And when I go back to that failure state that I had at 44, I think one of my issues beyond the 10 plus years of problems with my HPA and with cortisol production, one of my issues is that I was skimping on sleep.
Mm-hmm.
It's just kind of the nature of being a mother, a working mother or working father. And I can't tolerate that. Only about 3% of the population has the short sleep gene where they function well on 6 hours or less per night. So the other 97% of us, for the most part, need to really pay attention to circadian rhythm. And, for me, I was working full time at 44 as a practicing functional medicine. And then I was writing my first book at night. And so my sleep was definitely affected. I was getting about 6 hours a night and using caffeine to kind of make up the difference, which I think of now as a high interest loan. And so, I really had to pay attention to this. And, what happened over that time is that I steadily, somewhat below the radar, gained about 20 pounds, and that's inflammaging was part of this process.
So when you did this research for the book, you looked at the genes, you looked at all of the markers, telomere test, all of the other biomarkers, some of which you talked about earlier, and you put this all together. What's your current take on the best way to measure aging? I mean, there's still a lot that we don't understand about aging and what it even means and how to measure it. So where did you come out on that?
Yeah, I came out a little disappointed, honestly, because I wish we had, one simple blood test that could tell you definitively. But here's where we are. And I do want to answer your question about one of the stress genes, the FKBP5.
Right. We got to go back to that.
So I talked about telomeres kind of at the beginning in the way that I defined a failure state for myself. And they're a good marker, but they're not perfect. So despite what you might hear from telomere books, it turns out that cancer cells, for instance, have longer telomeres. That's part of the failed homeostatic mechanism, is that the telomeres are longer. So you can get, if you're looking at the question of rapid aging, telomeres can give you a false negative. Mm-hmm. So they're not a perfect test. If you look at the Baltimore longevity study, one of the markers that they think is the most helpful is interleukin 6, which is one of those cytokines or chemical messages of inflammation. Hand grip strength. I'm a fan of using any markers that are free. And hand grip strength is a good one. It's used in a lot of the studies of aging, especially older folks. And the way that I work on my hand grip strength is to hang from a bar, like a pull-up bar. I go to bar class about 4 times a week, and I hang from a pull-up bar for about 1 to 2 minutes. And so, testing your hand grip strength is another way of looking at this. So there's a lot of different ways of looking at aging. I think some of the inflammatory markers beyond interleukin 6 can also be helpful. Do you have a way that you measure it, Chris?
Not quickly like that. I mean, I just put together a picture with a number of these different markers, inflammatory markers, some of the cardiovascular disease risk markers. I look at cognitive markers for cognitive function. I guess the shorthand version is it's kind of a gestalt at this point, and I'm looking at mostly markers of inflammation from a biomarker perspective. But this isn't something that I've looked into in as great of detail as you have.
Well, what I do the same thing. I create a gestalt, and what I did was to put together kind of the latest thinking on how to track the aging process. And I have a quiz, kind of a lengthy quiz that you can do to assess your health span. And, there's the real age quiz, for instance, which is now about 15 years out of date, doesn't include a lot of the latest thinking about inflammation. But if people are interested in doing that quiz, we can mention that as well. So that's what I use, kind of the quiz together with some biomarkers.
Okay.
And fasting blood sugar is another good one. I think it's another way of kind of looking at the failure state and how's your glucose homeostasis. That's a really important predictor of the aging process. And when I turned 50 2 weeks ago, I was very sad to discover a study that showed that your fasting glucose goes up by about 10 points by age 50. And then it continues to climb if you don't do anything about it, depending on diet and sleep and these other levers of health span, kind of that period of time where you feel like you're in your prime and your biology is working for you. And it continues to climb by about 10 points every decade. So I think fasting blood sugar is kind of the easiest thing that people can get from their conventional doctor, and it's a really important biomarker.
Let's return to FKBP5 and the role in the stress response in PTSD. I just did a presentation, not last weekend, but the weekend before at UCSF on the myth of adrenal fatigue, and I talked about genetic an epigenetic reprogramming, rather, of the HPA axis that can happen even in utero that leads to changes in cortisol levels throughout a person's entire life. And I didn't go into any detail on the specific genes and gene expression involved there, but I'm curious. A lot of the research I've seen is the same as what you refer to, the Holocaust and the Dutch hunger cohort, and then 9/11. There's also Norrbotten, the far northern part of Sweden, and the feast and famine kind of research there. So tell us a little bit more about this gene and its role in the stress response, and then how stress affects our physiology.
Yeah, well, this gene, FKBP5, is involved in your HPA. And I agree with you. Traumatic stress has lasting effects on your body, and then it can also affect your children and your grandchildren via epigenetic change. So when I struggle with my stress response system and my telomeres, my fasting blood sugar, my cortisol levels, it's helpful to know that it's not necessarily all you. That it could be related to the stress your mother or grandmother felt. And in my
Yeah.
case, my mother was going through a divorce when she was pregnant with me, so she definitely had a lot of stress. And it was at a time in 1967, it was the era of Twiggy, and so she was underweight and only gained about 20 pounds with me. And then it wasn't trendy to breastfeed, so there were a number of epigenetic changes that occurred for me. But more specifically, let's look at the science. The person who's done, I think, the most compelling work in this field is Rachel Yehuda. So she's at Mount Sinai Hospital. She's a professor of psychiatry and neurosciences. And her work has mostly been on the Holocaust and the 9/11 terrorist attacks. And so first with the Holocaust, she looked at the genes of 32 Jewish survivors of the Holocaust. She lives in maybe the perfect area to study these folks. And then she looked at the genes of their children. And she compared, as a control group, their results to Jewish families living outside of Europe during the war. So she had a really profound control group. And her focus was FKBP5 because it's the gene that seems to regulate the HPA perhaps more powerfully than other genes. So what she found was epigenetic inheritance of the survivor trauma. So the DNA didn't change in the survivors, but the epigenetic marks did. And I think of those marks as being kind of like sticky notes that attach to the FKBP5 gene, and they increase your risk of post-traumatic stress disorder. So those sticky notes that she found in the survivors that attached to this gene were passed on to their offspring. So she also looked at the women who were pregnant at or near the World Trade Center in New York City during the 9/11 terrorist attacks. And she had a total of 35 pregnant women. Again, they had alterations to FKBP5, and they increased a woman's risk of developing post-traumatic stress disorder and then passing it on to her baby. There's another study that is worth mentioning because it was a different type of stress, and this might even be more relevant for our audience today. It was an ice storm in Canada that occurred in 1998. And what happened was a vicious cold snap. So they had severe sub-zero weather that led to power outages and extreme cold exposure that went on for several weeks. And people were basically homebound. They were stuck at home. So researchers have then tracked the women who were pregnant at that time, and their kids are now, 18, 20 years old. And they looked at genetic tags that were placed by the prenatal stress and then compared them to normal women. And again, they found that the DNA methylation signatures were different in the children of these women that were in utero during the ice storm and the cold snap. And what is profound to me is that they found that their immune cells showed profound differences. They had methylation in gene promoter regions, which are the switches for genes to be turned on and off, especially the genes that control insulin and blood sugar and maybe even immune function. So this provides even more evidence of the epigenetic switch that can occur during severe stress.
Yeah, and as I was saying before, it's really crazy to see how much these genes can affect every part of physiology. And we now know there are connections between changes in their circadian rhythm and blood sugar regulation, inflammatory signaling, which, as we talked about, virtually affects every chronic disease that we know about so far, affects changes in hormone balance and regulation, because we evolved in this environment of 24/7 light-dark cycle that was unchanged for billions of years, really. And it wasn't until the last 150 years that we developed artificial light and the ability to, get exposure to light at night, and that affects our circadian rhythm. And it's just this gigantic experiment. So it's not really surprising, actually, to me, to recognize that changes in the expression of these genes can have such a profound impact on our health.
Yeah, huge. And, I think it's helpful maybe to just talk briefly about the Dutch famine study, because it points to a few other outcomes. So if we didn't get your attention with the diabetes and the genes that can regulate your risk of post-traumatic stress disorder, when you look at the Dutch famine, that data is really compelling to me, because this was 1944 in Western Netherlands. There was a German blockade of transport, and it led to a catastrophic drop in food availability. And people barely survived on a dramatic reduction in the calories that they were getting each day. Some even dropped down to 600 calories per day. They were so desperate, they were digging up tulip bulbs to eat.
Yeah.
And they then got liberated by the Allies in 1945, and they had 20,000 people who died of starvation. So the women who were pregnant before, during, and immediately after the famine, they then looked very carefully, because the Dutch keep such meticulous health records. And now these famine babies, there's about 2,400 of them. They're now, about 70 years old. And they know that the babies born to those women who were in the Dutch famine, they had a normal birth weight. So they were able to, kind of get what they need from their mothers, but their children were fat. So the offspring, the Dutch famine grandbabies, had neonatal adiposity. They were fatter babies, and they also had poorer health later on. And then another piece that I think is interesting is that if you look at the brains of the people who were in utero during the famine, they have accelerated aging. So there's about 300 adults that survived, and the most recent data shows they have definitely weaker hand grip strength, they have weaker muscles, they have physical frailty, and their brain function, especially attention and focus, is compromised compared to controls.
All right, I want to talk about one last thing here, which is meat. It's always fun to talk about meat. And, we earlier talked about this new, maybe not new, but a shift in the idea that there's not just one diet that's best for anybody. Of course, we've been talking about this for years, but I think this concept is starting to get out there more in the mainstream, and I'm glad to see the discussion shifting maybe a little bit from, low carb or low fat, or, everyone, this idea that everyone should do the same thing, which is preposterous. So tell us what your thoughts are, which may be different than my thoughts or thoughts of other people who've been on the show, about meat consumption and an individual approach to that based on gene and environment interactions.
Sure. Well, I think in some ways you and I are very much on the same page, agreeing that there isn't one size fits all. And, even what worked for you 10 years ago might not work for you now.
Yeah.
So for most of my life, I've been an omnivore. I had a period of time in medical school when we were doing anatomy dissection where I was just so grossed out by the fat and the flesh that I went vegan. And when I went vegan, I dropped weight. I had no energy. And frankly, I looked like I was on the cover of National Geographic. Like my boobs deflated. I probably had almost no estrogen, almost no pregnenolone. So, I come at this from a place of being an omnivore. But what I've found is that there's some very interesting work especially by Martin Blaser,
Yeah.
looking at the microbiome and how it's involved in estrogen modulation. So specifically what's known as the estrobolome. And what I suspect personally is that when I eat more red meat, I tend to recycle estrogen to excess.
Mm-hmm.
So the concept here is that your gut microbes can influence your systemic estrogen levels as they contain certain enzymes like glucuronidase, which render estrogens reabsorbable. So it may be that modulation of the estrobolome could be helpful. And this seems to be more of a factor for women than men, but for women, it may impact your risk of breast and endometrial cancer, maybe even diabetes, and for men, more your risk of prostate cancer. So I have to acknowledge that the evidence here is limited. Much of it is association, not causation. Most of it is observational. But women who eat more meat seem to have higher serum estrogen levels. Now, it could be other things that they're having with the meat. Maybe it's the barbecue sauce or the bun or the French fries cooked in industrial seed oils. Maybe it's SIBO. Maybe vegetarians are less stressed. We don't really know. But I do have a gene called PPARG, which seems to perform better with marine fat compared with animal fat. And observational studies show that there's more weight loss in women who have this gene variant who eat more seafood compared to meat. So there's some other evidence that supports this, pretty much all observational, including after menopause, eating red meat can increase your breast cancer risk by a modest amount, about 22%. Dairy consumption is associated with higher estrogen levels. Vegetarians have lower estrogen levels than omnivores and have a lower risk of breast cancer. But, maybe it's fiber. Maybe it has nothing to do with the meat versus no meat. Japanese women definitely eat less meat than American women. They have lower rates of breast cancer, but who knows? Maybe it's the green tea. So, so I say this because, I love your work. And I think part of the takeaway here is what's the N of 1 experiment? In many ways, a randomized trial is the gold standard that we have in medicine. We're kind of stuck with it. But the N of 1 experiment, I think, is even more important when it comes to figuring out what's the truth for you when we talk about this, gene environment interaction.
Yeah, it's very much underrated, actually, I think. I mean, certainly when we have to be aware of the limitations of n equals 1, like the person, and I think the biggest limitation or concern is that people use n equals 1 experience and extrapolate that to assume that will be other people's experience as well. So, for example, the diet evangelist, someone whose life was changed by a low-carb diet or a vegan diet or whatever, and then assumes that everybody else will have the same experience. But if you do understand the limitations of n equals 1 and you know how to properly perform those experiments, it can be incredibly powerful. And, at the end of the day, this is why I'm always having this conversation with patients. No matter what you believe, your body is the final arbiter. So if you think a ketogenic diet sounds really cool and you're convinced by, what people are writing about and talking about in relation to it, and then you try it and you stick with it and you feel like a total train wreck, then what's more important factor there in that decision? I would argue that it's your experience.
Oh, for sure. For sure. I totally appreciate that. And, I don't think I'm a food evangelist. I think I'm more of a food agnostic because I really I want people to do this N of 1 experiment. And I'm not saying that I don't eat meat. I mean, you know that because I've shared a cow with you. My freezer might have a little bit more meat than yours, but leftover. But I totally agree with you. I went on a very strict kind of paleo regimen, and I could get to a body mass index of 23, and I couldn't get lower than that. And so for me, my N of 1 experiment showed me that if I want to fit into my clothes, I need a few more carbohydrates, I have to modify. And I tried a ketogenic. I think you and I talked a little bit about this a couple of summers ago. I went on a ketogenic diet with my husband. I was, my usual kind of obsessive way of going about it and checking blood ketones throughout the day. So I was in ketosis for 3 months and I gained 14 pounds. It was a disaster. There's about 10 different enzyme defects that can make you have a lot of difficulty and inflammation with a ketogenic diet. And I probably have one of those. So this N of 1 experiment, I think, is just a really important way to be thinking about, how to slow down the aging process, how to reduce the inflammation that's at the root of all the chronic disease that we're talking about.
Yeah, and this is something that always comes up with patients. In fact, I can think of several off the top of my head who I thought would be a great candidate for a ketogenic diet. They have a number of conditions that would benefit from it. They're overweight. They have some neurological issues, neurocognitive problems, maybe chronic infection. They're kind of the poster child for benefiting from a ketogenic approach. And yet, when they do it, and even with a lot of tweaking and sticking with it to get through that difficult transition period of, fat adaptation and trying exogenous ketones and trying different ratios of macronutrients and lowering protein intake and, adding some low intensity aerobic exercise like walking and, all the tweaks. And not to say that there still aren't others that might have worked, but, it's at some point, you start to realize that you're kind of beating your head up against the wall trying to fit a square peg into a round hole. And that, for me, fortunately, that doesn't go on for as long because I don't have the belief that it should work for everybody.
That's right.
Yeah. So, well, Sara, thanks so much for coming on the show. It's always a pleasure. And I appreciate your balanced and measured approach and your evidence-based approach, but also your consideration of other factors outside of the framework of the, cherished randomized controlled trial, which is we all know has shortcomings, and those shortcomings have become even more apparent lately with the work of John Ioannidis and others who've pointed out the inherent flaws in our current research paradigm. So it's great to see how all of those different perspectives come together in your book, Younger, and tell people, when is it out and where can they find it and anything else they should know about it.
Yeah, so my book is out. It's available anywhere books are sold. You can get it on Amazon, Barnes & Noble, or your local independent bookseller. And I really want for people to care about aging. That's kind of my bottom line, and to care about the N of 1 experiment. Those are the two biggest takeaways. The other great part here is that you're never too young, you're never too old to care about aging.
Yeah, I agree with that completely. And I've seen pretty remarkable turnarounds even late in life for people who've never really thought much about this. So it's never too late to start. And yet, the earlier you do start, the better. So if you're a young person listening to this, it might be harder for you to think about the perils of aging because you haven't really had an experience of your own mortality or morbidity, perhaps. But the sooner you can get tuned into some of this stuff, the better your chances for a long, healthy lifespan will be. So thanks again, Sara, and I'll see you next week, but we'll make sure to have you back on the podcast for your next book, which I'm sure there will be one.
That's for sure. Thanks, Chris. Thanks, everyone.
All right. That's the end of this episode of Revolution Health Radio. If you appreciate the show and want to help me create a healthier and happier world, please head over to iTunes and leave us a review. They really do make a difference. If you'd like to ask a question for me to answer on a future episode, you can do that at chriskresser.com/podcast question. You can also leave a suggestion for someone you'd like me to interview there. If you're on social media, you can follow me at twitter.com/chriskresser or facebook.com/chriskresserlac. I post a lot of articles and research that I do throughout the week there that never makes it to the blog or podcast, so it's a great way to stay abreast of the latest developments. Thanks so much for listening. Talk to you next time.